So a fun little lesson here, evaluating, where we're starting to evaluate some trigonometric ratios using exact values rather than relying on our calculator every time. And we will be relying on these strategies on an assessment when it comes. So there are two common triangles that we can draw that can be easily created. So we're going to not necessarily memorize what the triangle looks like, but we're going to memorize how the triangles come to be, how the triangles are sketched. And we're going to be able to use these triangles to find exact values for our primary and from that our reciprocal trigonometric ratios for three common angles. We're going to use, we call them special angles, and these angles are 30 degrees, 45 degrees, and 60 degrees. So we'll start off with our first special triangle. Now what you need to remember is we start off our first special triangle with two side lengths, two sides, one here, one here. There's a right angle in between them, and both of these side lengths are 1. That's the only part you need to memorize. The rest is analysis. So we need to come up with here, and I apologize, it looks like my, doesn't look like a perfect isosceles triangle, but that's okay. So now we're analyzing it. Okay, the first thing we need to do is set it up like a triangle. It only had two sides. We need to give it its third side like so. And from here, we need to come up with this third side length. Well, we can do that relatively easily. We learned how to do something like this in grade 9. We use our Pythagorean theorem. So our Pythagorean theorem says that 1 squared plus 1 squared is going to be equal to the square length of the third side. So I'm working with 1 plus 1 is equal to c squared. I'm working with 2 is equal to c squared. And then I can take the square root of both sides here. Okay, I have to take the positive and negative. Square root c is equal to plus or minus the square root of 2. Fantastic. Now, I suspect you can guess what the side length is here. Is it positive the square root of 2 or negative the square root of 2? Well, a negative length doesn't actually make any sense. So given the context here, the negative solution is inadmissible. Inadmissible. And we're working with the square root of 2, positive the square root of 2 as our third side length. Great job. That's some of our work done already. Now the other idea, another idea that we're using as we analyze this triangle is the sum of interior angles. I know we already talked about this. This is the sum symbol. So the sum of interior angles in a triangle is always 180 degrees. Well, that's great. Well, I know how many degrees are in here. This is a 90-degree angle. Okay, so that means that I'm working with 90 degrees plus, I don't know, I can call it angle A and angle B in here, plus angle A plus angle B is equal to 180 degrees. So that means I have 90 degrees. If I subtract 90 from both sides, angle A plus angle B is equal to 90 degrees. Well, that's great. What I need to do here is look at the symmetry of the triangle, because if I go around the triangle this way, I see a side length 1 and then a side length square root 2. And if I go around the triangle this way, I find a side length 1 and then the side length root 2. So there is no difference in how I'm going around this triangle. And that symmetry that we observe here, we can use that to logically assume that angles A and B are going to be equivalent. And if angles A and B are equivalent, then that leaves half of 90 degrees for each of them. We can use the logic, but A equals B, so A equals 45 degrees, and angle B as well equals 45 degrees. That's all of our analysis here. We have three side lengths, 45 degrees, and we have three interior angles. That's our first special triangle. You'll notice, again, the only part really that you have to memorize is the starting position. So we start off this special triangle with two lines, side lengths 1. The rest of the work we accomplished through analysis. So let's try out special triangle 2 over here, and then we'll start working. We'll analyze the triangles and we'll see what we can do with them. So special triangle 2, we're going to start with an equilateral triangle. So I want everyone to draw an equilateral triangle on their page, something like this. And you know what? I'll make it slightly bigger on my page. Just to fit the same size as my first triangle. There we are, something like this, something like that. There we go. Now, this equilateral triangle has side lengths 2 everywhere. That's it. That is our starting position. The rest of the work we're going to do here is going to be accomplished through analysis. Now, according to the same logic we used before, the sum of interior angles is 180 degrees. Okay, that's great. Now, as an equilateral triangle, all angles are going to be equal. So that means angle 1, angle 2, and angle 3, or angles A, B, and C, are all going to be equivalent. And if that's the case, then each angle is going to be 180 degrees divided by 3, because I have 180 degrees to go around. There are 3 angles I'm working here, and every interior angle here is 60 degrees. All right, great job. We've made it this far. Now, we want to get in here, and we actually want to cut our triangle in half. So we'll head straight down from our top corner here. Straight down, we're cutting it in half. There we go. Now, if we cut this in half here, this angle right here is going to be exactly 90 degrees. All right, so we have a right angle there. Now, we only actually need here for our analysis the right half of the triangle. So what I'm going to do is erase what I don't need. Don't need this angle. Don't need that side length, don't need this side length. I'll have to make this one, I'll have to correct it there. There we are. This is the half that we're looking at. Now, if that's the case, we need to make a couple of adjustments, because this side used to be 2 units long, but it was cut in half. So it's no longer 2 units long, it's now 1 unit long. This angle up here used to be 60 degrees, but then it was cut in half. And since it was cut in half, now I have a 30-degree angle right at the top here. So my interior angles, and if I wanted to, I could double check. My interior angles still sum up to 180 degrees. I have 90 degrees in here, 60 degrees there, and 30 degrees there. Fantastic. Now, the last piece of analysis we're going to work with here is to find our unknown side length, because right now we only have 2 side lengths. So we need right here this side length. How can we come up with this? By using our Pythagorean theorem again. So this time our hypotenuse is has side length 2, and the unknown side is not a hypotenuse. So I'm working here, and I know, okay, so 2 squared is going to be equal to 1 squared plus, we'll call it theta squared. Whoops, sorry, we shouldn't call it theta. We should give it a side length. I don't know, we'll call it b squared. Good stuff. So, okay, so 4 is equal to 1 plus b squared. Okay, so that means 4 minus 1. I'm working with 3 is equal to b squared. So b is equal to plus or minus the square root of 3. Using the same logic as last time, our negative side length is inadmissible. So our side length that we're working with here is the square root of 3. There you have it. We have now sketched 2 special triangles. One looks like this, one looks like that. Now, what I encourage you to do right here, we are going to be relying on these special triangles for the rest of this chapter and for the entirety of the next chapter as well. So you're not going to be given these special triangles on a summative. You need to be able to sketch them on your own. So what I encourage you to do, flip your page over. Pause the video, flip the page over, and try sketching your special triangles once more. Go through the same logic we just used. You do not need to show you do not need to show your work for the sum of interior angles or for your Pythagorean theorem as you go through it if you're feeling comfortable to skip those, because you're always going to be doing the same logic, right? We're always working here. We know side length 2 and side length 1. Through the Pythagorean theorem, that tells us the third side length is root 3. We will feel comfortable with that memorized after working with these enough. So try it out, pause the video, unpause it when you come back, at which point we can start to interpret our special triangles. So the whole point here in these special triangles is to be able to evaluate our primary trigonometric ratios with these interior angles. So if I'm working over here, that means with special triangle 1, this has one special angle. This is special angle 45 degrees. So this should allow us to evaluate the sine of 45 degrees. Well, I know sine as a trig ratio is the opposite side over the hypotenuse. How do I know that? From SOHCAHTOA. All right, so sine is opposite over hypotenuse. I need to find a 45-degree angle. I could use this one, or I could use that one. It does not matter. All right, so I'll choose the one on the top. Now I need to find the opposite side length to that. I'm working with 1, so 1 divided by the hypotenuse, that's the square root of 2. So the sine of 45 degrees is equal to 1 over the square root of 2. That is it in exact value form. And if you're curious, try it out. Throw it into your calculator, the sine of 45 degrees, see what that is as a decimal. Put into your calculator 1 divided by the square root of 2. Check that out as a decimal. You should come up with the exact same value. So using that same logic, I would like you to try and find the cosine of 45 degrees. I would like you to try and find the tangent of 45 degrees. Pause the video here, try it out, and then come back to check your work. Good, I've moved mine over for a little bit more space. We should be working with the cosine of 45 degrees is 1 over root 2. The tangent of 45 degrees is equal to 1. Now let's head over to special triangle 2, and we'll use this to evaluate special angles 30 degrees and 60 degrees. We'll start off with 30 degrees here, and we should be able to find the sine of 30 degrees. The sine, I know that's opposite over hypotenuse. Good. Now I know my opposite side to 30 degrees. I need to identify this angle. Opposite to 30 degrees, I'm working with 1. My hypotenuse is 2. So the sine of 30 degrees is 1 over 2. Nice work. Okay, if that's the case, I should be able to find as well the sine of 60 degrees. So the sine of 60 degrees here, I'm working, and you know what? I'll change my color in here. We'll work with blue. The sine of 60 degrees. All right, again, I'm working with my opposite side divided by my hypotenuse. And my opposite side to 60 degrees this time is the square root of 3. My hypotenuse is still 2. Fantastic. So from there, you should be able to find the cosine of 60 degrees. You should be able to find the tangent of 60 degrees. And you should be able to find the cosine and the tangent of 30 degrees as well. I would like you to try those out. Pause the video, try them out, and come back to check your work. And we should be able to see here the cosine of 30 degrees, the square root of 3 over 2. The tangent of 30 degrees, 1 over root 3. The cosine of 60 degrees is 1 over 2, and the tangent of 60 degrees is root 3. Fantastic work there, folks. Now, we would like to use these values to show that the tangent of theta is equal to the sine of theta over the cosine of theta. We will be relying on something like this later. It's just a bit of a precursor, but we should be able to set this up by checking it. Now, if we're checking something like this, you will have set them up before. We're going to explicitly go over the do's and don'ts of how to check something like this in the future. We'll explore it a little bit here. If we're checking something like this, we need a left side, right side check. I know you've done these before, but perhaps you've done them maybe a little bit willy-nilly. We're going to explicitly follow some steps. So if we're setting up a left side, right side check, then we always need to set it up with our very first line exactly what we're checking. So my left-hand side, as copied from here, is the tangent of 30 degrees. The tangent of 30 degrees. Good. You get 1 mark. If you're checking your work, you already, the tangent of theta, rather, my very first line. You get 1 mark already for copying it down exactly as you saw it before. My right side is the sine of theta divided by the cosine of theta. Now, something that is not showing up in here is an equal sign. And that's because my left side here might not be equal to my right side. I'm not allowed to use the logic that they're equal to one another. So I don't write that equal sign in. All right, that's very important because what we're doing here, the entire point in setting it up with a left side, right side check is to separate your left side, put it over here, your right side, put it over there. We're going to work with them individually. All right, so now we have our tangent of theta. Now we will still put in some equal signs, and you'll see, but here I put in an equal sign. This equal sign means whatever I'm going to write here is equal to what's above. It has nothing to do with what's going on the right side. I've had some students in the past who prefer to put their right side way over here just to make sure they're not tempted to start combining the sides. All right, so our tangent of theta. Okay, well, we know that we're working here with the tangent of 30 degrees because that's what they're asking us to find. Now, the tangent of 30 degrees, we know how to find something like that, right? How do we find something like that? We can rely on our special triangles. Now, I encourage you, do not just write your special triangles at the top of your page and always refer back to them, because then you're not getting the practice that you need. You're going to be relying on these special triangles when you get into grade 12 as well. So let's practice them. We have the tangent of 30 degrees. A part of this solution, you earn marks in a problem like this for showing your special triangles, for showing how to evaluate something like this. So the tangent of 30 degrees, I need to sketch a special triangle that has a 30-degree angle. So that special triangle, I remember, comes from, it starts off, with an equilateral triangle. I'm trying to sketch it in an okay manner. With an equilateral triangle that we're going to cut in half. So my interior angles, I have 60 degrees here. I'll have a 90-degree angle there. I'm cutting it in half. Oops, and that side length is 2. Good, I'm cutting it in half. So now I have a 30-degree angle up top. I have a side length of 1 down here, and from my Pythagorean theorem, I know I'm working with the square root of 3 on this side. Now, if it took you a little bit longer to come up with that triangle, that's fine. I expect it to. I have sketched these special triangles hundreds, maybe even 1,000 times. You folks have just sketched them perhaps only the once, or only the twice. So we will get there. I can use that logic. Okay, if I'm evaluating the tangent of 30 degrees, well, I know that tangent is my opposite side over my adjacent side. And I know my opposite side from 30 degrees, that's 1, okay? My adjacent side to 30 degrees is root 3, so I'm working with 1 over root 3. So the tangent of 30 degrees way up here, I'm working with 1 over the square root of 3. Good job, us. Now, we can always check our work with what we did at the beginning of the problem, beginning of the lesson here. The tangent of 30 degrees, lo and behold, 1 over root 3, good job, us. So my right-hand side, I'm working with the sine of theta over the cosine of theta. Now let's work over here. Okay, so again, I do have an equal sign, but this equal sign means that whatever I'm writing here is equal to what's above. It has nothing to do with the left-hand side of my equation. So I'm working with the sine of 30 degrees. I'm dividing that by the cosine of 30 degrees. Okay, well, the sine of 30 degrees and the cosine of 30 degrees, I can use the same special triangle to come up with those values. So the sine of 30 degrees, okay, I know that's equal to my opposite side over my hypotenuse. Fantastic. I know my opposite side to 30 degrees is 1. I know my hypotenuse is 2. I'm working with 1 over 2. The cosine of 30 degrees I'm working with right here. Okay, so that's going to be my adjacent side over my hypotenuse. My adjacent side to 30 degrees, I'm working with the square root of 3. My hypotenuse, I'm working with 2. So then I can substitute these values up into my left side, right side table. I'm working with the sine of 30 degrees, so that was 1 over 2. And this is being divided by the square root of 3 over 2. And I'll write this as a sideways fraction. There we go. And then I'm just going to move this over to give ourselves a tiny bit more space here. So whenever you have a fraction divided by a fraction, it's going to help you out to split it up. So we write it as 1 over 2 divided by the square root of 3 over 2. Good. And then I know how to divide fractions, right? So that's 1 over 2 times 2 over root 3. Good, so I'm working with 2 divided by 2 times root 3, and then I can simplify this because I see a common factor in my numerator and denominator. It simplifies to 1, and I'm working with 1 over root 3. That was my goal. It was my goal to find 1 over root 3 just from the left-hand side, and to find 1 over root 3 just from the right-hand side here. Now that we've done that, we can say, okay, fantastic work. Our left side is equal to our right side. We can say that with a therefore statement if we want. Therefore, my left side equals my right side. Fantastic work. So I would like you folks to follow that same process. Try it out for 45 degrees here. Try it out, and when I upload this to the classroom, it will include that solution. All right. Now let's go forward a little bit more. We're going to use our exact values from our special triangles to evaluate these expressions down here. We'll work through 2a together, and then 2b I'll ask you to do on your own. So 2a, okay, all right, so we're working with the sine of 30 degrees. Do I know how to evaluate the sine of 30 degrees? Yes, I do. How do I evaluate something like that? Once more, I'm using my special triangles. So this special triangle, I'll encourage you, pause the video, sketch the special triangle, unpause it, and check your work. When I'm sketching this special triangle, I have my side length 2. I know this bottom side length was cut in half, so now it's side length 1. I know this was my original 60-degree angle. I have a right angle here. This was 60 degrees. It's been cut in half. It's a 30-degree angle. And using my Pythagorean theorem, I know that this side is square root of 3. Now from here, I can evaluate, okay, so the sine of 30 degrees is going to be equal to my opposite side divided by my hypotenuse. You're seeing the repetitiveness in this lesson. That's a good thing. That's what this skill really relies on. My opposite side to 30 degrees, I'm working with 1. My hypotenuse is 2. So the sine of 30 degrees is equal to 1 over 2. So when I'm evaluating this, I start off, and I've evaluated the first one. That's 1 over 2. And then I work forward. All right, so now I need the cosine of 45 degrees. So I check, okay, does this triangle have a 45-degree angle? No, it does not. In order to evaluate the cosine of 45 degrees, I'm going to need another special triangle. So we know how it starts. Pause the video, try it out. Good, so we start off with one side length 1, another side length 1. We analyze this, we give it a hypotenuse. We know that's the square root of 2 from our Pythagorean theorem. We have a 90-degree angle here, a 45 up on the top, and a 45 down here. So the cosine of 45 degrees, okay, well, I know I'm going to be working with my adjacent side divided by my hypotenuse. Well, my adjacent side to 45 degrees is 1. My hypotenuse is the square root of 2. So I can substitute in up here, that's the sine of 30 degrees times the cosine of 45 degrees, and that's 1 over the square root of 2. And then I need the tangent of 30 degrees. So I check, okay, do any of the triangles that I've already sketched, do they have a 30-degree angle? Yes, they do, the first special triangle. So I can use that to find the tangent of 30 degrees. The tangent of 30 degrees is going to be equal to my opposite side over my adjacent. And that is going to be equal to, I'm working here, my opposite, that's 1 over the square root of 3. So this is times 1 over the square root of 3. Now, if I'm multiplying 3 fractions together, I just multiply their numerators. So 1 times 1 times 1, that's 1, divided by their denominators. So that's 2 times the square root of 2 times the square root of 3. We know how to work with radicals in here. So this simplifies to 1 over 2 times the square root of 6. Nice work, folks. Try out that same logic, that same strategy. You should be able to handle example 2. Like I said, it will be uploaded with the note on the classroom. And lastly, we have one more example to work through here. We'll probably work through both A and B. Now, 3A. All right, so I'm working with the sine of theta, and the sine of theta is equal to the square root of 3 over 2. So I'm kind of going through the same logic that we've already used in this lesson, but I'm going to go through it backwards. So, all right, you can kind of, we notice a little part of this question, if theta is in between 0 degrees and 90 degrees, you can kind of trust that right now. Trust me, we'll understand that a little bit more after we've worked into lesson 4.7. So if I'm logically going through this, okay, the sine of theta is equal to the square root of 3 over 2. That means that my sine of theta, well, I know my sine of theta, that's my opposite side divided by my hypotenuse. So my opposite side divided by my hypotenuse is equal to the square root of 3 over 2. So I need to find some kind of an angle that has an opposite side, a triangle that has an opposite side to an angle of root 3, and that has a hypotenuse of 2. If I'm going to do that, I need to, you guessed it, sketch a special triangle. So pause the video, try it out. Come back to double check your work after you've done it. So I should be working here. I need my special triangle that has a 30-degree angle up here. It has a 60-degree angle down here and 90 degrees inside. hypotenuse is 2 because it was originally an equilateral triangle. My side length here is 1 because this one was cut in half. And from my Pythagorean theorem, I'm working with the square root of 3. So I need to identify which angle inside this triangle has an opposite side of the square root of 3. So if I look here, the opposite side to 60 degrees, that's the square root of 3. So from this special triangle, I know theta is equal to 60 degrees. Fantastic work, folks. Now, example 3b, I'll get you started, but then you should be able to finish it on your own. You might notice, okay, this one looks a little bit more challenging, and it is at first. But if we recognize, okay, what we're trying to solve for is theta. So let's isolate the trig ratio. Trig ratio. Fantastic. Because we're not able to isolate theta itself. We'll isolate just the ratio. So I'm working here. Okay, so I'm going to need to subtract 4 from both sides. So I'm working with 1 is equal to 2 times the cosine of theta. Good, and then I need to divide both sides by 2. So I know that the cosine of theta is equal to 1 over 2. Now, all of a sudden, this is a special triangle you should be able to sketch. So try it out. Try to finish solving this on your own. Like I said, the solution will be on the Brightspace Classroom. Nice work, folks.